as you can see, we have moved from bearing and distance. We are now on elevation and what? Depression. All right. Elevation and depression is a topic that we have taken together before, but we want to use this opportunity to quickly review it with students so that our memory can be refreshed and we can at least strengthen ourselves again towards the examination ahead of us. I want to quickly summarize some basic information you need to remember about elevation and depression. Under elevation, we have what we call the angle of elevation. The angle of elevation is the angle. From my end, I will call it the angle that is just between your looking straight and looking up. There is always a particular angle between when you look straight and when you decide to look up, and that is the elevation angle. Of course, the depression angle will also need a way of looking straight first before you now look down. Representing that in diagram, we have a tower standing, and this is the eye level of a particular man that is represented by M. That is his eye level. He is looking straight. I've represented my looking straight with a broken line. The man decided to look straight, and he now looks at the top of the tower. The angle between is looking straight and looking to the top of the tower is my angle theta, which is called the angle of elevation. I want to emphasize this again, that students should note and note carefully that there will never be angle of elevation if there is no reference line of your looking straight. So before you think of elevation, you must always assume that there is a looking straight first, which is we will call our reference line. That is your looking straight. Before you now say you want to look up. Don't place any angle of elevation without putting the reference line of looking what? Straight. The same thing for depression. If this is, of course, a tower, it will have, this is my ground level now. GL is my ground level. There is someone here, and somebody decided to climb up the tower, and he now lied down. But he decided to look straight at the top of the tower. Now, you want to look at the bottom of the tower. The angle between is looking straight and looking down is depression, alpha angle of depression. And that is angle of depression. You also look at this diagram that there is also a reference line of what? Looking what? Before we can fix the angle alpha, that is called our angle of depression. So, for both angle of depression and elevation, the reference line of looking straight must always be emphasized, located in your diagram. It will interest you to establish one fact here. Because this line is parallel to this line, the angle alpha here will be equal to this angle theta. And if I close this up, this represents elevation. Looking at the top of a particular thing is representing elevation, because this will now turn to high level. And this representing what? Depression. And if you bring the two together in a particular diagram, they will be equal to each other, because those angles now, they are called alternate angles. Are we communicating? Yes, sir. Great. So, with this foundation being established, it is important to know that when you are given any question under elevation and depression, the first thing your examiner wants to see is the right diagrams. where you will have placed your right angles of both elevation and depression. It is also possible for you to take elevation and angle of elevation and depression from the same point. How does that look? That's interesting. How does that look? Look at this. Let's assume this is a tree. And there is a mango tree. And there is a mango that you are interested in on top of the tree. Of course, this is the ground level. You are standing. That's the boy that is interested in the mango on the top of what? Top of what? The tree. So he was actually looking at the mango. That there's a mango here. And this is the boy. The ground level, my GL. And this is your mango tree. It's becoming very interesting that this boy is looking at this mango and he needed to move close. But somebody now look at it and say, what is your angle of elevation of that mango? It is not this. It will be stupid of anybody to say the angle of elevation is this one now. No. Because I have just said that for you to get the angle of elevation, even though it's looking at the mango, you will now have to say, let me assume I have looked straight towards the tree. Then I now decided to look at the mango. That is when the angle of elevation can come out. But as soon as we establish this angle of elevation, the boy saw a snake. There is a snake there. He was looking at the snake. He's looking at mango. He's looking at snake. How that shows that you want mango, you want snake at the same time. Hello, class. You want mango, you want what? Snake. So the one that you prefer out of it, is it mango you prefer or what? Snake. So if you want snake, go to mango. If you want mango, go to snake. But what are we bringing out here? He's standing, looking at mango. He's standing, looking at snake. He's standing, looking at mango is elevation. He's standing now. There is already looking straight here from the same point. He's not changing his position. From the same point, he's standing, looking again at the snake is what? Depression. Depression. So you can have both angle of elevation and depression from the same what? Point. Am I still communicating? Yes. With this understanding, I just need to call your attention that there are 4 applications that you should also put behind your mind and go and review in preparation for your exam, which we have discussed in our previous classes, that they are cosine rule, your sine rule, your trigonometric ratio, and Pythagoras what? That is also applicable for elevation and depression. Can we take our first example, example 1? Students, please, let's pick our pen and let's write so that we can write quickly so that we can manage our time effectively well. Okay. Are we set? A man 1.7 meter tall. A man 1.7 meter tall. Observe the angle of elevation of the tip of a tower, to be 35 degrees. A man 1.7 meter tall observes the angle of elevation of the tip of a tower to be 35 what? 35 what? Degrees. Full stop. He moves 50 meters away from the tower. He moves 50 meters away from the tower And now observe the angle of elevation to be 28 degrees. He moved 50 meters away from the tower and now observes the angle of elevation to be 28 degrees. Full stop. How far above the ground is the tip of the tower? Correct with 3 significant figures. How far above the ground? How far above the ground is the tip of the tower? Correct to 3 significant figures. That's a word problem on elevation and pressure. And this question is not even asking us illustrate the information in a diagram. Did it say that? Did the question say that? So are we saying because the question did not say illustrate the information in a diagram, you will not do a diagram? You cannot solve elevation and depression problems without drawing the diagram. I've emphasized diagram drawing in our previous classes. I'm emphasizing it again, that it is important for you to note that the first challenge you need to overcome is read the question, understand perfectly well, then translate into diagram. Can we do that together? Somebody should help us. The man is 1.7 meters tall. Let me put my diagram here. The man is 1.7 meters tall. Can the man be standing in the air? Hello, class. Can the man be standing in the air? He's not a magician now. So you don't expect the man to be standing in the air. Obviously, you know there is a ground level. When they say a man, this is what we call common sense. And everybody what? Everybody has common sense. So. Yes or no? Yes, so there is nobody created of God that does not have common sense. And it is important, it is not God that will help you use your common sense. Who will help you use it? You are the one to use your common sense by yourself. So when you are also solving mathematics, we must always learn to use our common sense. Is the class with me? Yes, sir. We must learn to always use our common sense. Great. So this is the ground floor. The question did not say there is a ground floor. The question said a man 1.7 meters tall. Observe. Can he observe without standing on the floor? And because the question is also talking about his height, we must show the height now. When the question does not talk about the height of that man, and the man is talking about a man, and it's not talking about the height, then the height of the man is negligible. Science students should know what negligible is. That is of no importance. It's of no importance. All right. I want to assume this is my 1.7 meters. Are we together? Yes, that is the man. Yes.
Observe the angle of elevation of the tip of the toe to be 35 degrees.
Okay, that means there is a tower. That is my tower. A tower is a very tall building. See, standing on the ground floor. This is my ground floor. I mean ground level. Okay? It's observing what?
The elevation of the tip of the tower to be 35 degrees.
Okay? If this is the man, he wants to observe the elevation of the tip of, I can call this place T, tip of the tower as 35 degrees. With what we said in the introductory part, it is now established that this man cannot establish that elevation angle of elevation without looking straight. So, you must first of all look straight. That's our reference line. Then you will now look at the top. With that, this angle will now be my 35. That is angle of elevation.
He moves 50 meters away from the tower.
50 meters away from the tower. Is it 50?
Yes, sir.
All right. Let me shift my line carefully so that I can use that space for diagram. He moves 50 meters away. Or, sorry, so that I can manage my space. I will quickly redraw. .7 meter, the ground level, the reference line. This is top T, and this gives us 35, right? Yes, degree. Okay, so I can move my line back so that we can. All right, this is the man. This is the high level. All right. You now move 50 meters away from the tower. Will you move here? Yes or no? He's moving away. Is it moving away? Is it English language or maths? English. English. Sometimes ago, I said, when your English is bad, mathematics is in trouble. Because if he says 50 meters away, it does not mean if this is the tower, then it should move away. That is the meaning of away. Then this is where the man is now. And it's still 1 point. Will the height change? Thank you. That's common sense. The height will not change. All right. Yes.
And now observe the angle of elevation to be 28 degrees.
It's observing again elevation to be 28 degrees. Before you can observe elevation, you must look straight and look up. And now this place is 20 what? Can I quickly put letters here? If this is A, B, C. Let's call this place D. Let's call this place E. Maybe I can just call this place F. I like putting letters in my diagram so that I can manage the diagram very well. With this diagram, is there, this is 50, thank you. That's 50. It has moved 50 meters away. Is there anything strange here? No. They are just trying to play around with words. And all we need to do is to interpret the question correctly after drawing it. With this diagram drawn, what are they asking us to find?
How far above the ground is the tip of the tower?
That's it. How far above the ground? So you want to find this distance. That's the distance you want to find. How far? The height of the tower. But part of the height of the tower, is it not already 1.7? Shebi? Yes, so if I want to deal with this question, I will be less concerned with the remaining height downwards. DC is already known. All I will calculate is now TD. And if I want to operate with TD, I will operate with the triangle on that floor from the eye level of the man. Yes or no? Bringing that out, I will now have something like this. This will be 28. This will be 35. This is E. This is F. This is D. And this is T. Yes or no? Yes, and you agree with me that the 50 of AB is the same thing as EF. Yes, why? Why? Opposite sides of a rectangle, they are always what? Equal. So, this place should be what? 50, which is our EF also. And what I said in the past is that whenever you have, this is what we want to find now, H. Whenever you have a challenge like this, always try and look at the existing right angle triangles in that diagram. It is allowed that you can separate it. Managing your space, you can separate it carefully so that you can see how to deal with the diagram separately. Do we know FD? Class, do we know FD? So I can call it X. So in triangle TFD is a right angle triangle, yes or no? Yes. That's the first right angle triangle that I can see in that diagram, right? Yes, in triangle TFD, comma, opposite over the adjacent, tan 35 will be, yes. No. No. He moves 50 meters away from the tower. And now observe, it is where he was standing before. I like your point. But where he was standing before is, from there, the question is saying he moved. He now moved. He now moved. He took the first elevation. The first elevation is 35 degrees. He now decided to move away. That's what the question is saying. If the question is, he moved 50 meters away from foot of the tower, be from here. I mean, it can't be from here. You are he also standing some meters away already from the foot of the tower. He was standing some meters away. He was already standing away from the foot of the tower. He now moved away 50 meters from the foot of the tower. If you are saying the measurement should be from here, then how do we want to establish this 28? What establishes this 28 is that the farther you move away from this angle, the lower the angle should become. Fundamentally, looking at me, I'm standing, I want to get the elevation of the top of the roof of this building. Somebody will say, the mathematics teacher is looking at the top, is standing and is looking at the top of the roof, is taking an elevation of the roof of the building. He now moved 20 meters away. You cannot start saying, that shows that his reference point is where he was standing before. Yes. The reference point is obviously because you are taking the elevation of the top of the tower. That's why the question is saying he's moving away from the tower. So it does not mean you have to start measuring from the tower. I want us to separate it carefully, and I think I'm communicating. Young man, so if the distance between the man and the foot of the tower is of importance to the question will have said something to give us insight into that. But what the question said from the beginning, that the man is standing, the man 1.7 meter, standing, and is taking elevation from, taking elevation of the top of the tower. He's not talking about that distance. But after that, he said he moved away. He cannot now go and be measuring that 50 from the tower. It is the 50, that shows you must leave wherever you are and move away 50 meters from the foot. He was standing some meters away from the foot before. He's moving away 50 meters now. That's the English there. But it's a good observation. Can we appreciate that guy for me? So, please, interpretation of question is also important. Interpretation of the question, because if you put that 50 here, that will be a problem. That will be a problem. So, we can continue what we are doing. Yes or no? Yes, tan 35 will be what? H, that's opposite over the adjacent. That's h over s. This implies that h is equal to x tan 35. This also implies that h is equal to what? 0.7002x. Yes.
We should use the tan to find the value, like find the angle of the, like the angle of elevation from point A to E.
Point
A to E, like from the other diagram.
This one?
Yes, it's only 35, and it should be.
How? The question gave you 35.
Yes.
Okay?
And the angle of elevation from A to F, rather.
A to, where is A?
The AB down.
This one.
Yes, to F.
You can't get 35, obviously. It cannot be 35. I'm sorry. The angle of elevation from A to this point and the angle of elevation from A to this point can never be the same thing. It can never be the same thing. I'm sorry. I'm sorry. It can never be the same thing. Under mathematics analysis, that will not be the same thing. You should also know that this point, this point is even further than this. I hope we are not getting ourselves confused. Are we on the same page?
Yes, sir.
Okay. This point, point A here, is even further than point F. You cannot get this. What we are saying is this. Look at this. This angle and this angle, we are saying is the same thing. Under plane geometry, it cannot be the same thing. Under analysis of mathematics, it cannot be the same thing. Because even if this line is parallel to this line, the transversal here cannot be the same thing as the transversal here. Obviously, this angle should be equal to this angle. That is what? Corresponding angle. So, but are they on the same? They cannot. This line cannot come here. CED in triangle CED. What's ED now? ED will be 50. If you look at this is TED, so that you will see what I'm saying. This is 28. The ED here will now be 50 plus X. It was standing before. It was already away. It will even be wrong, except the question says it expressly. It was standing before. It was already away from the tower. Therefore, there is no way, the only the reference point you are having is position now. He now wants to move away. He cannot now go and start measuring that 50 again from the tower. It should be from where he was standing. Come on. It should be from where it was standing. So I want to move 50 meters away again, even though it is it not, is it moving, is it 50 meters away? Is it not from the tower? It's moving away from the tower. If I'm standing and I'm standing, this is a wall here, and I'm standing some meters away from the wall, and I want to move 20 meters away from where? Away from where again? Is it not from the wall? So you still take that wall as your reference point. Am I communicating? Yes, class, am I communicating? Yes, this is English language. Am I communicating? Yes, great. So opposite, this place is CH. Opposite over the adjacent, you have tan 28 is equal to h over 50 plus x. It implies that h is equal to 50 plus x into tan what? Into tan what? So you have this, this implies that h is equal to 50 plus x into what? 5317. Open that bracket for me. H is equal to 50 multiplied by 0.5317. 26.58. 58. That says 586. 26.585. Okay. Plus 0.5317x. This is my equation what now? 2. If you look at equation 1 and equation 2, both are equal to h. Right? So I can equate them to each other. So I will say equating equation 1 and what? 2. I have what? 0.7002x is equal to 26.585 plus what? 0.5317x, right? Collection of like terms. Are we on the same page, class? Yes, you have 0.7002x minus 0.5317x should be equal to 26.585. Why did I say minus? You can see that this is plus. Your equation, normal linear equations, you have two sides, your left-hand side and your right-hand side. As you move any entity from one side to the other, what happens? The sign changes. It was plus before, so it's moving to my left-hand side, then the sign must what? Change. The sign must change. Can you do the subtraction? 0.1685x is equal to 26.585. Finally, x is what? 26.585 divided by 0.1685. What's that? 157.77. Meters, I guess. Okay. That is x. Where is x? This is x. X is FD. X is what will help me to get h. Do I need, is x our final bus stop? No. Is x our final answer? No. So I may have to I can use equation 1 now. Let me use this space. Okay, I can use this space. Can I use this space now? Okay, I can use this space. So finally now, h should be 0.7002x, but x is 157.77. So 0.7002 times 157.77. What's that? 110.47 meters. Is that our final answer? I got yes somewhere. I got yes somewhere. If your answer or response to my question is yes, you are losing attention gradually. You are losing grip on what the question is asking you to find. The question says we should find the height of the tower. But remember, we are finding TD. The height of the tower is TD plus DC. So we still have to add 1.7. So the height of the tower is equal to 110.47 plus 1.7. What's that? 11 meters. So is there anything? Oh, so three significant figures. 112.17 to three significant figures should be 112. Thank you. 112 meters to 3. That's the final answer to that question. The pilot of an aircraft, 2,000 meters above the sea level, 2,000 meters above the sea level, observes at an instant that an angle of depression of two boats. The pilot of an aircraft 2,000 meters above the sea level observes at an instant that the angles of depression of two boats which are in direct straight line are 58 degrees and 72 degrees. 58 degrees and 72 degrees. Full stop. Find correct to the nearest meter. Find correct to the nearest meter the distance between the two boats. Find correct to the nearest meter the distance between the two boats. Class, are we okay? Okay, I'll take the shot the last time. Please, let's be on the same page. Okay? Yes, great. The pilot of an aircraft 2,000 meters above the sea level observes at an instant that the angles of depression of two boats which are in direct straight line are 58 degree and 72 degree. Full stop. Find, correct to the nearest meter, the distance between the two boats. Find, correct to the nearest meter, the distance between the two boats. Are we okay now? Yes. This question is on depression. The first question or the first example we treated is obviously a question on what? Elevation. We are trying to at least remind ourselves again of the fact that there are ways to place your angles of elevation and ways to place angle of depression, reading or translating our question into what? Diagram. Thank you. Into diagram. All right. Okay, the pilot of an aircraft. Oh, I hope my students is not sleeping. All right. Okay, can we be on the same page now? Please check the question carefully before you give me information here. The pilot of an aircraft. 2,000 meters above the sea level. That shows naturally. This is another common sense that we want to use now. A pilot of an aircraft, 2,000 meters above the sea level. Will 2,000 meters above the sea level be on the ground level? Will pilots be on the ground level? So, the pilot, I'm assuming this is where my pilot is. This is my pilot. Above the sea level. This is sea level. Right? You said 2,000 meters. Yes.
Observe at an instance that the angles of depression of two boats which are in direct straight line are 58 degrees and 72 degrees.
Oh, there are two boats. Boat 1. Thank you. Boat 2. And they said they are in direct straight what? Line. This pilot is looking at the two boats at two different angles of what? Depression. He's looking what? Down. Is he looking up? No. He's looking down. So, before we can get angle of depression, we established that as introductory part this morning, that there must be a straight line, that is our looking what? Straight. Before we decide to look what? Down. And decide to look what? Down. The angle between looking straight and looking down is the angle of depression. The first one is what? Hello? Look at this. This angle and this one. Which one is bigger? If this is K and this is M, which one is bigger? 58 and 72. Which one is bigger? 72. So it is clear that this angle should be 72 and this one should be what? 58. What is that again in play? Common sense. It is a common sense that will tell you 4 is a bigger number than 2. Yes or no? That one is a common sense. Is that mathematics? No. Okay? If there are two, for me, you are saying you have 2 sons and you are putting money inside their account and you want to give them their pocket money, but you want to make transfer. You made the first transfer 50,000. The second one 30,000. And the boy with 30,000 came to say, Daddy, why is my money bigger than? Or the boy with 50,000 came complaining to Daddy, Daddy, why is my money smaller than my brother's money? And you kept wondering. You kept checking your transfer. I made a transfer of 50,000 into your account, and your brother's own is 30,000. Your younger brother's own is 30,000, and you are complaining that your own is smaller. Is that mathematics? My students are sleeping. Is that mathematics? No. What is it? Common sense. So, as much as possible, I want to re-emphasize in this class, when you enter into mathematics exam, let us switch on our common sense. It's important. There are so many things that it is a natural reasoning that you will use to pick out of the situation, not just what your teacher told you in class. Will your teacher tell you that you need any teacher to teach you that 50,000 naira is a bigger money than 30,000 naira? That's not the responsibility of any teacher. It's the responsibility of our brain, which we must always what? Use. All right, this angle and this angle, what is their relationship? They are alternates, that means they are equal, right? Yes. This angle and this angle, they are what? Alternates, and that means they are equal. Naturally, I've also said to us, sometimes ago, that as we move close to as angles shift position, as moving close to angle 90, the angles will be what? will be increasing. As the angles move away from angle 90, the angle should be what? Decreasing. And this diagram has actually obeyed that law. So we can continue. Madam. Oh, they are asking us to find correct to the nearest meter the distance between these two boats. Boat 1 and boat. Quickly, how many right angle triangle can you see? 2. You can see that I enjoy using the right angle triangle. So, the height is given. This place is Y. This place is A. This is P. And this is A. Can I quickly bring out this triangle, small, in a smaller way for us to see? If this is P, this is the right angle, this is 72, this is what? B1, right? And this is A. This is Y, thank you, and this place is 2,000 meters. I can find Y. To find Y, opposite over the adjacent. So tan 72 is equal to 2,000 over Y. It implies that Y is equal to, or it implies that Y tan 72 is equal to 2 what? 2,000. This also implies that Y should be 2,000 divided by what? Tan 72, which is 2,000 divided by 0. Okay, sorry, 3.0777. Okay? Can you give us the final value of Y? 649.84. And should be in meters. All right, that is the value of Y. I want to take the second diagram. The second diagram is Y plus X here. This is 58. This is 2,000 meters. This is P, Abi. And then this is what? This is B2. And this is A. Looking at this diagram, I can say that opposite to angle 58 degrees, opposite over the adjacent will give me tan 58. So I can say tan 58 is equal to 2,000 over Y plus X. But Y is already what? 649.84. Therefore, tan 58 into 649 649.84 plus X is equal to what? 2,000. Are we following? Can we open that bracket? What is tan 58? 1.6 into 649 is it 0.84? Oh. Okay, opening the bracket. 1.6003 times 649.84. What's that? Again? 1039.94 plus 1.6003x will be equal to 2,000. That's the equation we want to solve. Yes or no? Bringing the equation to this space, I have 1039.4.94 plus 1.6003x is equal to 2,000. Collection of like terms, I have 1.6003x is equal to 2,000 minus 1039.94. Somebody do that subtraction for us. 96. Okay, finally, x should be 960.06 divided by 1.6003. What's that? 592. To the nearest meter should be 600. To the nearest meter, your final answer is equal to 600 meters. This is to the nearest what? Any reaction, any confusion, observation, clarification, please talk to me so that we can move forward with what we have to do today.